Good morning. Let's continue our talk about standard deviation and areas under curves, and maybe let's create a little bit more, continue this idea of applied examples that we started in the last time. Last time we talked about Jane and Mike for the most part. This time we want to continue this idea of taking a specific number and finding out where the percents were, maybe in particular finding some different ways. Last time we focused almost exclusively on left-tailed distributions. Let's talk about some right-tailed variations and even some middle terms as well. I did want to remind everyone that we do actually have the requirement, of course, in this whole section and pretty much moving forward in this class of being normal. And we had said that one way to measure normal was if you drew the histogram and saw that it was building a basic bell curve. Another way to decide normal is that it has to have no more than one outlier. And I think we defined outliers to be bigger than the third quartile plus 1.5 the interquartile range. So you have a normal amount in the middle and you go to the bigger one, you multiply that normal amount in the middle by 1.5 and that gives you a little stretch there. And you're saying if you've got stuff beyond that, think of those control charts with things that go beyond 3 or 4 or 5 standard deviations. Those things are not normal. And so here too, if you've got more than one outlier, you say this data is not normal. So if your histogram looks skewed instead of looking perfect, bell-shaped, that's not normal. If you've got more than one outlier, maybe that's not normal. But I find one of the easiest things to do is to calculate Pearson's index. You just take x bar minus the median times 3 and divide it by standard deviation of your sample that you've got, so a little less. If you do that, that number should be in between -1 and 1. If it is, we say it's normal. If the number is more negative than -1, or if it's more positive than 1, so 1.01, 1.2, something like that, then we start to say that it's a little bit skewed, and that doesn't mean normal anymore. And so these percents that we talk about stop making sense because we no longer have the empirical rule. We have to go back to Chebyshev's. So, having said that, let's take a look at this problem. Spending $40 daily on search ads, so click advertising. There's many popular search providers that do this. There's of course one obvious one, and then there's several other competitors that kind of don't come close. A website sees 200 new clicks per day, on average. There's a normal standard deviation of about 20 clicks. If the website gets 2 new clients for every 100 clicks, what is the chance that on a particular day they see fewer than 2 new clients come to the website and decide to purchase a product? What's the chance of more than 4 new clients in a particular day? What's the chance of having 2 to 4 new clients a day? This would be very interesting if you're starting a website of some sort and you want to advertise your product, your company, because after all, you probably need to know, based on the number of clients, how many staff you have to employ to create your product. I don't know. I was looking at, we just finished the Valentine's holiday, and so everyone was selling strawberries that are dipped in things. And I imagine dipping strawberries takes a lot of effort and time. You have to do it by hand probably, otherwise they get all mushy. So this could be a very interesting and curious thing to be looking at and thinking of. So let's take a look. First of all, notice that we've got a couple things in here that are just a little bit odd. So I'm actually going to first of all break out this pen. And I think maybe at the beginning of class I mentioned this idea, not the beginning of this video, I mean the way beginning of the whole term, this idea that we have to be careful to figure out what we can ignore. And as important probably as it is that we're spending $40 a day on search ads, for us, in this particular example, that's not all that important. It would be for the company, I admit. And of course, if we took 240, we could figure out the cost per click, and that might be interesting to talk about as well, but that's not what we're discussing here. We're focusing specifically on a couple pieces of info. We have 200 clicks as an average, and we have sigma equals 20 clicks. That's the first thing I'll highlight there. The rest of this is just kind of a little bit of background information that maybe we don't care too much about, with the exception of this, because here we have to make sure our units are the same. They talk about 2 new clients a day for every 100 clicks. So when we're asked about 2 new clients or less than 2 new clients, what we really mean? Less than 200 new clicks, right? Because one client represents, 200 should be times 2, 400. 2 clicks for every 100, so if we want to have 2 new clients, yeah, I can't count, can I? Just ignore me for half a second while I reboot my brain. And it's happening. If we get 2 new clients for every 100 clicks, less than 2 new clients should be less than 100 clicks. Now I can count. Greater than 4 new clients is talking about greater than 200 clicks. And 2 to 4 new clients, we're talking about between 100 and 200 clicks. I can't spell either. Clearly I need more coffee. All right, let's make sure that this is making sense. On average, we have 200 clicks a day, okay? We have a standard deviation of 20 clicks. For every 100 clicks, we get 2 new clients. So if we're curious about less than 2 new clients, we're curious about less than 100 clicks. If we want more than 4 new clients, we need to double that. So we need to double our clicks and talk about more than 200 clicks. And if we want between 2 and 4, it should be between this many. And we've successfully converted their client question into a clicks question. And that's important because we need to talk about clicks and clicks and clicks so that we can successfully write this up in a z-score table. This means that the 3 questions we're asking are, what is the area of the normal curve lower than 100 clicks? So maybe question A, question B, and question C. You can see I'm not very good at drawing normal curves. Question A is curious about what's going to happen if we are at less than 100 clicks. So here's 100 clicks. Here's the 200 click average. We're curious, what's the chance that we would fall in this range? We want to find that area that I've shaded. For question B, where we're curious about more than 200 clicks, here's the 200 average. That's mu. We're curious about more than this. So we're curious about the shaded area. And lastly, between 100 and 200, we're curious about this area. These are the 3 areas we want to find. To do that, we use z-scores and a normal table. So first we have to convert everything to z-scores. So we can do that calculation. This is the raw score line. We want to find z-score. Z-score says you take your raw score count of 100, you subtract the average, in our case 200 clicks, and you divide it by standard deviation, in our case 20 clicks. This is going to be negative 100 over 20, which is going to be negative 10 over 2, which is called negative 5. Right? If I can count. Okay. Well, negative 5 is quite a very large z-score. In fact, if you look it up on your chart, you'll find that we have a convention. At the bottom of the chart for the negative side, it says, for z-values less than negative 3.49, use 0 to approximate the area. When we drew it up with 100 and 200, it looked okay, but in reality, 5 standard deviations to the right is a very far distance this way. It's very different from what we normally expect. And so we expect this total area to the right of negative 5 to be about 0.000. Very small. Highly unlikely. So what's the chance that we have less than 2 new clients in a particular day under this structure? Non-existent, really. It would be very, very strange for us to not have 2 new clients a day with this website. For B, how do we calculate this? Well, again, we can calculate the z-score, but if you look at the shape of the graph, you've already noticed something. Namely, this guy is the median. We're curious what's the chance that we get the average stuff. In particular, what's the chance that we get more new clients than average? An average being right in the middle, there should be a 50-50 chance on either side. That's what this picture is showing. That's what a z-score of 0 says. If you look up a z-score of negative 0.0, or if you go on the other side and look at 0.00, you'll find that 0.50 is the area. That's the area to the left. And so 1 minus 0.500 happens to also be 0.500. And that tells you the area to the right. We've snapped it in half perfectly. So there's a 50% chance that we might have more than 4 clients. And finally, here, we're curious about the area in between. And for find the area in between, in this case it's a little silly. But I wanted to prove a point about this 0 with the 5. But the general idea is that you would take all the area to the left of the larger one, and then you would have to subtract off this area, the area to the left of the smaller one, to find just your area in between. You take a big area and you subtract off this area here until you found just the in-between area. But of course, because fewer than 100 clicks is so unlikely for this company, what with a 20-click standard deviation, we find ourselves having practically 0.5000 for here as well. 0.5 minus this 0.1 gives you the range in between. You have some other examples in the homework in your book that discuss this, maybe with some numbers besides zeros. Let's take a look then at what we can really find out with this type of idea. As long as our data is normal, we can look under the normal curve and we can expect to find ourselves areas. Areas to the left, areas to the right, areas in between 2 things. And while our chart is geared towards areas to the left, with subtraction, clever subtraction, we can always find ourselves just the area we're looking for. And I think it helps to draw out both your normal curve, shade in the area you want, and also talk about what are the raw points, and then convert them with z-scores into z-points, and then you can write out the areas like I did here. So in this case, we were curious, what's the chance of having less than 100 clicks? Well, if you look at 200 clicks and plus or minus 20, it seems like, well, we could have less than 100 clicks. That's doable. But when you plug it into z-score terms, less than 100 clicks is trying to find the area on this part of the graph. And when you plug it into z-scores, it's like, well, that's a standard deviation of 5, negative 5. And we want to be less than negative 5. That's very strange. 1, 2, 3, I mean, your 5 levels of normal that way. It would be very, very odd for that to occur. If you're talking about bigger than something, that's where our table that we've got won't give us the right answers, so you have to do 1 minus this area to the left and subtract it off. 1 to go the whole distance, and then subtracting off the area to the left to get you whatever's going to be remaining on the right. And if you want to be in between 2, well then, you're going to want to get your biggest area, and then you're going to want to subtract off your smaller areas so you just have the area in between those 2 pieces. That's one thing I want to do. Another thing I wanted to do with this lesson, because I think that this section maybe is pretty much straightforward as long as you've got normal data, which of course, by and large in this textbook, we're focused on normal data. You don't go back to Chevyshev's. That's a topic for a different stats class. I wanted to take a moment to chat with you about your midterm, because we're fast approaching that point in the course. The midterm exam is going to be, regardless for whether you're face-to-face or online, it is going to be computer-based. Very similar to the quizzes and the homework and all that you're seeing in your online homework product. If you are in an online-only class, you need to be registering with the Victoria College Testing Center. You need to get that registered and set up, and you have to tell them that you're taking a computerized test. You have to look carefully at the syllabus for the correct date range, and you have to go there. If you are face-to-face, of course, we will be having our midterm in class, but we will be meeting in a computer lab that day so that we can take the computerized version of the test as well. So, online you have a little bit more work to do because you have to make an arrangement with the testing center and you have to successfully schedule your exam in the right dates. If you don't schedule it in the right dates, you'll go there. The testing center may not know that you're scheduling it in the wrong dates, so you'll be perfectly happy right up until the point you try to log on to your course product and find out that the registration isn't working to open up the midterm exam because it's already saying past due. So, that's so much different for the two students. What's the same? Well, you're going to need to have your username and password. If you're using a Victoria College computer, then you need to be having your Victoria College username and password. If you are at a different college than VC, then you need to be having that, probably just to log on to the computer in their testing center or in the classroom testing lab. You're also going to need your username and password for your homework product. Many students have their browsers memorize those. I know I do it myself. And so suddenly you sit down at a new computer that does not have your username and password memorized and you panic. That's not a great feeling to start off the midterm with. You do want to have for yourself your TI-36X Pro. This is the only physical calculator I will be allowing on the midterm. The testing center is very strict on enforcing that, and I am just as strict in my face-to-face class. If you do not have a calculator, you have some other options. You, of course, are allowed to use Excel on your computer. You may have to open up Excel and activate certain portions of it. I think that's more important towards the later end of the class, but there's been some Excel videos, and of course you've got that Excel user guide, and you want to make sure that maybe your version of Excel, if you've added some add-ons to it, might be slightly different than the version of Excel in the computer lab. Any of the functions that I've written here, I know last time I had written norm.dist, those things are standard features of Excel, and any time in this videos that I talk about a feature of Excel that requires a plugin, I will mention what plugin that is. I gear the class towards the standard version of Excel. There are a couple plugins we'll use. I think it's mostly later on, but don't worry, those are free plugins that just naturally come with the standard Excel version. I should say free for a standard version of Excel. I've met once or twice, I've seen some, I don't know what they were, they're very strange versions of Excel that people were trying to use on home computers. Anyway, at the college computers and university computers, we're perfectly fine there. So you need your username for your school, you need your username for your homework product, you want to have your TI-36X Pro, which is my only allowed calculator, and I find that sometimes faster for students to use than Excel. You want to be practiced with that. And regardless of whether it's going to be face-to-face or online, I will have the formula sheet that came with your book. I will have some laminated copies of those available, one for each student as well. So you don't have to have any particular formula memorized. You have to do that much harder thing, know how to use all the formulas. The exams tend to be 50 to 75 minutes. I try to write the exams about the same time pacing as the quizzes have been. So if you've got a quiz that's going, you feel like the quizzes are not enough time, you want to practice more and more problems until you have a smooth level of proficiency with the problems that makes you feel like the quiz is enough time. I'm a big believer in practicing the testing environment. What do I mean by that? I mean that it's probably beneficial to go and grab some odd questions from your book from different sections that we've covered, write them on a sheet of paper separately, leave that sheet of paper or switch with a friend, and give yourself 70 minutes to sit down and take those questions, time it, use Excel and a calculator, but don't have your book open, and see what you score. Then trade off with your friend, grade those and score them. Practice testing is very beneficial. It does two things. One, it gets you over that test-taking nerves a little bit because you've done a lot of it. But two, it also means that you have an opportunity to see how you perform with the book closed. I have a lot of students after exams come up to me and say, I understood what you were talking about in lecture, I understood what the examples in the textbook were, I did the homework quite well, I even did the quizzes well, then I got the midterm and everything was bad. And if you delve a little deeper into that statement, invariably, I can't think of a single time when this wasn't true, what you find is that students were taking quizzes with their books open, which of course is fine. I don't enforce a closed book quiz rule, mainly because I can't with an online quiz. But you should be aware that then there's a difference between the quizzes and the exam. Namely, the exam is closed book. People use notes. People they do the homework and they take the homework and they do it in 5 hours and they have 2 tutors and a friend who took the class before helping them. That's not available on an exam. So you should be practicing for an exam in an exam-like environment, figuring out what do I need to know, what do I need to memorize, what's on a formula sheet if one's allowed, how does this calculator work, how does Excel work. Sometimes I think people spend some time on the homework and they code up Excel spreadsheets. I did this myself in classes that I've taken. I do the homework, I have my magic spreadsheet with all the formulas worked out in it, and so then it might be very easy to take a timed quiz when I had my spreadsheet, but of course for the testing computers you have to build up those formulas from scratch. Or maybe the formula sheet that we have doesn't have Excel formulas in it, and so you're used to always looking up whatever the Excel formula is, and so you get there, you have Excel, you've got your calculator, but you don't remember the formulas, and of course it's not open Google either. So I think there's something to be said for creating a test environment for yourself and practicing that. That's a good positive thing to do. I think that's probably about right for talking about the midterm exam. It's coming up here in just a couple weeks, I think, for all of our students. And then I think that that's probably good enough for today. So I will see you in the next section where we will talk just a little bit about trying to wrap up this idea of comparing one thing to the population and how we might extend things from there and get a better sense of what do I really mean when, say,